Here are our first force diagram examples from class. In the first example, a bowling ball sits at rest on the floor. There's the bowling ball, and there's the floor. To make a force diagram easy, it's best to make a system schema to get all the thinking done about what objects there are and what interactions are taking place, what forces there are. We have to identify an object of interest. In this case, it's the bowling ball. So I write BB for bowling ball, and I square it off to identify it as the object of interest. And now I want to think of everything that it is interacting with, and here they are. The bowling ball is in contact with the floor, so there's an interaction there, a force. It's not in contact with the whole mass of the Earth, but it interacts with the whole mass of the Earth, and that's the gravitational force, so we'll just get that in. That will always be there for all objects in all normal situations. And there's air touching the bowling ball, so let's think about possible interactions between the bowling ball and the air. If the floor weren't there, the ball would drop straight down, but the floor is there, so it exerts an upward force on the ball, and that would be the normal force we spoke about in class. The ball is not moving, so there will be no friction. Now, the air is in contact with the ball, and the only possible force that could be is the buoyant force. Any object submerged in a fluid will have a buoyant force, but for something like a bowling ball in air, that is a very small force, so we're actually going to ignore that. And a little more thinking about the interaction with the Earth, the floor doesn't have a gravitational interaction with the bowling ball. It's the whole mass of the Earth. So that's why we list the Earth as a separate item, because it's this whole mass of the Earth interacting with the whole mass of the bowling ball. Whereas the floor just interacts, it's a small piece of the floor and a small piece of the bowling ball in contact with it. So that's a different interaction. Now we're ready to make the force diagram. Any object that we're analyzing is just going to be a simple dot. So in that case, that's the bowling ball. And I want to draw the forces. I have two forces shown in the system schema, so I'll draw them. I have to figure out what direction they go. Gravity is always downward towards the center of the Earth, and so here's how we label. That will be G for gravitational force, comma, on the object, which is the bowling ball. By what object? Well, it's interacting with the whole Earth. So we have that. And then upwards is the normal force, right? If the floor weren't there, the ball would fall down, so there's an upward force perpendicular to the floor, and that's the normal force. It's on the bowling ball, and it's by interaction with the floor. And finally, since the ball's at rest, that's a constant velocity of 0. If these are the only two forces, they must be equal in strength and canceling out because the ball is not accelerating up or down.